It started as a routine comet observation. Another icy visitor streaking through the black. But what astronomers tracking 3I/Atlas saw next would stop them cold. A tiny interstellar object, less than a kilometer across, hurtling past Mars suddenly unleashed a massive cascade of exotic gases. And at the exact same moment, the Sun erupted with one of its most powerful flares of the decade. Coincidence? Or the first sign of a hidden cosmic connection? In late 2025, the Atlas Survey telescope in Chile flagged a faint, fast-moving point of light. At first, nothing unusual, until orbit analysts at NASA's Jet Propulsion Laboratory crunched the numbers. The path was hyperbolic, not elliptical. Translation: this object isn't bound to our Sun. It came from somewhere else, and once it slingshots around, it's gone forever. Only two other objects like this have ever been confirmed, 1I/Oumuamua in 2017 and 2I/Borisov in 2019. Both rewrote textbooks. 3I/Atlas, however, might be even stranger. Its inclination is just over 5 degrees compared to the Solar System's main plane, almost a head-on, retrograde trajectory, moving opposite the planets. That unusual slant makes close encounters possible, and on October 3, 2025, it passed within 0.19 astronomical units of Mars, about 28 million kilometers. Close enough for planetary scientists to get excited, but far enough to avoid danger to satellites or rovers. Even more surprising is its speed. JPL's Horizon system pegged its excess velocity at nearly 58 km per second relative to the Sun, more than 200,000 km per hour. For a body this small, that's blistering. Despite being under a kilometer in diameter, the nucleus of 3I/Atlas is no lightweight. Based on reflectivity and outgassing models, researchers estimate a mass over 30 billion tons. Think of a mountain made of exotic ice barreling through space faster than anything we can launch. But what's inside that mountain is the real story. Spectroscopy by Hubble and the James Webb Space Telescope revealed a cocktail of materials rarely seen together: carbon dioxide, water ice, carbon monoxide, carbonyl sulfide, atomic nickel, and cyanide. And then there's the scale of its atmosphere. The comet's coma, its surrounding gas cloud, is measured at over 180,000 kilometers across, with a dust tail stretching at least 100,000 kilometers behind it. For something less than a kilometer wide, that's like a matchstick creating a hurricane. The biggest shock came not from the comet's chemistry, but from the timing. As 3I/Atlas vented this exotic gas, the Sun erupted with a powerful X-class solar flare. Hours later, another flare followed. Solar flares aren't rare, but their triggers are usually internal to the Sun, twisted magnetic fields releasing pent-up energy. Yet some solar physicists noticed the eerie timing. Could this tiny visitor really influence our star? On paper, the idea sounds impossible. A 30 billion-ton comet compared to the Sun's mass is less than a grain of dust to a mountain. And yet, the data show a perfect overlap. If not causation, then at least uncanny coincidence. Within days, speculation exploded. Was this comet's composition or electric charge interacting with the solar wind? Could outgassed materials seed the interplanetary medium in a way that triggers instability? Others have floated even wilder ideas. Could 3I/Atlas be a fragment of something engineered? A dormant probe or debris from a megastructure drifting through interstellar space for eons? Its retrograde orbit and exotic chemistry certainly make it an outlier. NASA and ESA haven't endorsed any of these theories, but the unusual data have clearly rattled teams. The Minor Planets Center updated the comet's orbit hourly, and every available instrument, from ultraviolet to radio, has been pointed at it. For scientists, 3I/Atlas is more than a curiosity. It's a live test of our ability to track, predict, and understand unknown objects entering our solar system. Each new interstellar visitor is like a messenger from another cosmic neighborhood, carrying chemical signatures of worlds we can't yet see. With its close pass to Mars and then the Sun, 3I/Atlas offers a once-in-a-generation laboratory. If its outgassing spikes again, or if another solar flare coincides with its trajectory, that's data we'll never forget. NASA's Hubble and JWST will continue tracking the comet as long as it remains bright enough. Ground-based observatories in Hawaii, Chile, and the Canary Islands are contributing photometry and spectroscopy. Engineers at JPL are running calibration drills to ensure no detail is missed. The hope is to catch more outgassing events and see if they line up with solar activity again. If the pattern holds, it may open an entirely new branch of heliophysics. If it doesn't, we'll still have the richest dataset yet on an interstellar comet. And beyond the science, there's the cultural impact. Oumuamua sparked public fascination in 2017. Borisov made headlines in 2019. But 3I/Atlas combines both speed and mystery, a small, exotic object coinciding with our star's moods. That's the kind of story that captures imaginations. It's a one-way traveler slicing through the solar system with a composition hinting at a very different birthplace. And for a brief moment in 2025, it seemed to reach across space to touch our own star. Is it triggering the sun? Probably not. But the fact that we're even asking the question shows how much we still don't understand about the forces at play in our cosmic neighborhood. One thing is certain, astronomers will be watching every move until 3I/Atlas fades into the blackness between stars, taking its secrets with it, or revealing them to us just in time. If you love exploring the edge of space science, interstellar visitors, and cosmic mysteries that challenge everything we thought we knew, hit subscribe and ring the bell. We're following 3I/Atlas and other missions step by step, bringing you the discoveries as they happen. Thank you for watching my channel.